Before we begin, find yourself somewhere comfortable. Let your shoulders soften, your breathing slow, and your attention drift just a little inward. This is a story told at the pace of starlight, meant for quiet hours, for moments when the mind doesn't need to hold on so tightly and curiosity can exist without effort. There is something moving beneath your feet right now. Not the slow shuffle of continents, not the sudden shudder of an earthquake, but something deeper and far more patient. An invisible motion, steady and ancient, unfolding in a place no human has ever seen and no human ever will. It has been there for almost as long as the planet itself, quietly shaping the conditions that allow forests to grow, oceans to breathe, and life to persist under a restless sun. We often imagine Earth as solid and still, a reliable surface beneath our steps, but this stability is an illusion born of scale. Beneath the crust lies a world of heat and pressure, of metal flowing like a slow ocean. At the very centre rests a solid inner core, a sphere of iron and nickel glowing at temperatures that rival the surface of the sun. It remains solid not because it is cool, but because the pressure is so immense that its atoms are locked tightly in place, unable to melt despite the heat. Surrounding this solid heart is the outer core, thousands of kilometers thick, made of liquid metal in constant motion. It moves slowly, only a few kilometers each year, but over geological time that motion becomes powerful. The liquid iron rises and falls, twists and circulates, driven by heat escaping from the planet's interior. And as it moves, it generates something extraordinary. Electrical currents flow through this metallic ocean, and those currents give birth to a magnetic field. This is Earth's invisible shield. It rises from the depths and stretches far into space, forming a vast protective bubble around the planet. Most of the time, we never notice it. We walk beneath it, sleep beneath it, build our cities, and tell our stories beneath it, unaware that it is quietly turning aside a constant storm of charged particles streaming from the sun. The solar wind never stops. It rushes outward at hundreds of kilometers per second, carrying energy that could strip a planet bare over time. But when it reaches Earth, it meets resistance. The magnetic field bends those particles away, guiding many of them toward the poles where they slip into the upper atmosphere and paint the sky with slow curtains of green and red light. The aurora is not a threat. It is a sign of protection working as intended, a gentle glow that reminds us something unseen is standing guard. Without this shield, the story of Earth would look very different. Other worlds offer quiet warnings. Mars once held rivers and lakes, a thicker atmosphere, perhaps even conditions suitable for life. But its magnetic field faded long ago as its core cooled and stilled. The solar wind took its time, peeling away the atmosphere molecule by molecule, until water vanished and the surface grew cold and dry. Venus followed a different path, but it too lacks a global magnetic shield, and its oceans are long gone. Earth escaped those fates not because it is special, but because its interior stayed warm, its core kept moving, and its magnetic heartbeat continued to pulse. Long before complex life emerged, long before the first cells learned to divide and adapt, this invisible force was already there, holding the atmosphere close, allowing chemistry and chance to do their quiet work. It is easy to forget how fragile this balance is, because it has lasted so long. Billions of years create a sense of permanence, a feeling that some things are simply fixed. The magnetic field feels like one of those constants, as dependable as gravity or the rising of the sun, but it is not fixed. It breathes, it strengthens and weakens, it responds to forces deep below and far above, always adjusting, always changing, even when the changes are too slow for a human lifetime to notice. Sometimes the sun reminds us of this relationship. During powerful solar storms, great eruptions fling clouds of charged particles toward Earth at tremendous speed. When they arrive, the magnetic field flexes and compresses, absorbing the impact. Energy ripples through the upper atmosphere and even into the ground. Long ago, before satellites and power grids, such storms filled the skies with light and made compasses quiver. Today, they can interfere with technology, a small reminder that our modern world still depends on ancient planetary processes, and yet, even then, the shield holds. It has held through ice ages and mass extinctions, through the rise and fall of countless species, through every human story ever told. It is not perfect, and it does not promise safety forever, but it has been reliable enough to let life take root and complexity flourish. It has been reliable enough that we rarely think about it at all. Perhaps that is its greatest gift. The most important systems are often the quietest, the ones that ask for nothing and announce themselves only in moments of beauty, like light shimmering at the edge of the night sky. You do not need to understand every detail of how this shield works to appreciate it. It is enough to know that it exists, that it has been working patiently beneath your feet and above your head for longer than imagination can comfortably hold. And if your thoughts begin to drift here, that is perfectly fine. This story is in no hurry. The planet itself is in no hurry. In the next part of our journey, we will follow a single point where this invisible force touches the surface, a place explorers once struggled across frozen landscapes to find. We will trace its slow, surprising journey across the top of the world and discover why even something as steady as North does not always stay where we expect it to be. After spending a moment with the invisible shield itself, it feels natural to follow where that unseen force touches the surface of the world, to trace it not as an abstract field, but as a place, a destination, a quiet point that has drawn human curiosity for centuries. If you imagine the magnetic field like a great breath rising from Earth's depths, then the magnetic poles are where that breath seems to meet the skin of the planet, slipping quietly in and out of stone and ice. For a long time, people assumed North was fixed. The stars were steady, the axis of the world unchanging, and direction felt like something you could trust without question. Sailors learned early, however, that the compass needle did not point exactly toward the place where the planet spins. There was always a small disagreement, a subtle angle between true north and magnetic north, a reminder that even guidance can be approximate. Maps marked this difference, navigators adjusted for it, and life went on. It was not until the 19th century that anyone went looking for magnetic north itself. In the summer of 1831, a small expedition moved slowly across the frozen emptiness of the Canadian Arctic. Ice stretched in every direction, a landscape of stone and silence where the horizon seemed endlessly patient. James Clark Ross, a British naval officer, was searching for something that could not be seen, something that existed only as a sensation, a tug on a needle. When his compass finally tilted downward, pointing not toward the horizon but directly into the ground beneath his boots, he knew he had arrived. The magnetic North Pole was not marked by a mountain or a monument. There was no dramatic sign, no natural boundary. It was simply a place where invisible lines of force plunged vertically into the earth, a quiet convergence hidden within the ice. Ross planted a flag, recorded the position, and moved on, unaware that the point he'd found was already on the move. Because the magnetic pole does not belong to the surface, it is an expression of the deep, restless ocean of metal far below, and as that ocean shifts, so does the pole. At first, this movement was subtle, almost polite. Over decades, it drifted a few kilometers at a time, wandering gently across the Arctic like a slow animal following a path only it could sense. Expeditions returned occasionally to find it again, to note its new position, to confirm that North was still, more or less, where it had been before. But patience does not mean stillness. As the 20th century gave way to the 21st, the pole began to change its behaviour. The slow wander became a steady walk, and then, quite suddenly, something closer to a run. Year after year it moved farther, faster, pulling away from Canada and heading across the frozen ocean towards Siberia. The acceleration was unlike anything recorded since humans began tracking the magnetic field with precision. Compasses did not fail, but they needed correction more often. Navigation models required updates sooner than expected. This was not the planet panicking, it was the planet adjusting. Deep beneath the Arctic, two vast regions of magnetic influence compete quietly with one another, like slow tides in a metal sea. For much of recent history, the stronger of these regions lay beneath North America, anchoring the pole nearby. But strength is not permanent. Over time, the balance shifted. The Siberian region grew more influential, the Canadian one weakened, and the pole responded in the only way it could, rolling gently but decisively toward the stronger pull. For a while, it seemed as if the motion would never slow, as if north itself had decided to abandon familiarity. Then, just as quietly as it had accelerated, the pole eased its pace. The dash became a brisk walk, then something calmer. Scientists watched, measured, debated, and waited, knowing that whatever was happening was rooted thousands of kilometers below, far beyond direct observation. What matters here is not whether this movement signals something dramatic or merely another fluctuation in a long, complex rhythm. What matters is the reminder it offers. Direction is not as rigid as we imagine. The idea of north, so essential to maps and journeys, is tied to processes older than mountains and more fluid than water. It is shaped by heat rising from the center of the world, by metal flowing in darkness, by patterns that unfold over years and centuries without regard for human schedules. And still, life adapts. Airports repaint runway numbers when magnetic headings drift too far. Navigation systems update quietly in the background. Most people never notice the change at all, and that is a kind of success. The wandering north does not demand attention. It simply continues, an expression of the same slow breathing you felt in the previous chapter, now made visible through motion instead of light. If your thoughts begin to soften here, that is perfectly all right. You can let the image of the pole gliding across ice fade gently into the background, like a ship disappearing into mist. The planet does not need you to watch every step. It has been finding its own way for a very long time. In the next chapter, we will follow this path a little deeper, into moments when the magnetic field grows weaker, when the shield thins and the sky itself begins to change, not with urgency, not with fear, but with the same quiet curiosity that has carried us this far. As the magnetic north continues its quiet journey across ice and water, it invites a deeper question, one that does not rush or demand an answer. What happens when the invisible shield itself begins to thin, when the steady breath of the planet grows softer, and the space above us presses just a little closer than before? Imagine standing beneath a clear night sky, far from any city lights. The stars are sharp and patient, and the darkness feels deep rather than empty. Now imagine that the sky begins to glow, not just near the horizon, not just at the poles, but everywhere at once. Curtains of green and red light drift slowly overhead, stretching from one end of the world to the other. The air itself seems alive, gently illuminated by forces you cannot see. This is not a moment of danger. It is a sign that the magnetic field has loosened its grip, allowing more of the sun's energy to slip through. There have been times when this has happened before. The magnetic field is not a rigid shell. It is more like water held in motion, shaped by currents that rise and fall deep within the Earth. Most of the time, it remains strong enough to guide charged particles toward the poles, keeping the rest of the atmosphere comparatively quiet. But sometimes the flow in the outer core shifts. The patterns that generate the field grow tangled, less focused. The shield weakens, not all at once, but gradually, like a tide drawing back from shore. When this happens, the magnetosphere shrinks. The boundary between Earth and space moves closer. Particles that would normally be deflected begin to reach lower latitudes, slipping into the upper atmosphere in places that are usually calm. The aurora spreads, no longer confined to the edges of the world, but wandering freely across the sky. For someone living through such a time, the night would feel different, brighter, more restless, as if the heavens themselves were breathing closer to the ground. These periods are written into the planet's memory. Each time molten rock cools and hardens, tiny grains within it align with the magnetic field, freezing its direction and strength into stone. Each time fine sediment settles on the ocean floor, magnetic particles rotate gently, pointing north before being buried and preserved. Over millions of years, these quiet records accumulate, layer upon layer, waiting for someone to read them. And when they are read, they tell a story not of constancy, but of change. Sometimes the field weakens without fully turning over, entering what scientists call an excursion. During these intervals, which may last a few centuries or a few thousand years, the magnetic poles wander far from their usual positions. The field grows confused, complex, dotted with temporary poles that appear and fade. A compass would offer little guidance, and direction would become something you sensed from the land and the sky rather than from a needle. At other times, the process continues further. The familiar north and south slowly trade places, completing a full reversal. This is not a sudden flip, not a dramatic snap, but a long, uneven transition. The field strength drops, sometimes to a fraction of its usual intensity, before gradually rebuilding itself in the opposite orientation. Throughout it all, the planet remains intact. The oceans do not spill into space, the ground does not tear itself apart. Life continues, adjusting quietly to new conditions. But adjustment does not mean nothing changes. When the magnetic field weakens, more high-energy particles reach the atmosphere. These particles collide with atoms of nitrogen and oxygen, creating rare forms of matter that would not otherwise exist in abundance. They fall with rain and snow, settle into ice sheets, become absorbed by trees as they grow, and leave behind subtle chemical signatures. Thousands of years later, those signatures can still be detected, marking moments when the shield was thin and the sky was busy with invisible motion. The atmosphere itself responds. Increased radiation alters its chemistry, gently reshaping the balance of gases that protect life at the surface. The ozone layer, which absorbs much of the sun's harmful ultraviolet light, can thin during these periods, allowing more energy to reach the ground. The change is not usually enough to sterilize the planet, but it is enough to add stress, enough to make life work a little harder to maintain its balance. Weather patterns can shift as well, not uniformly but unevenly, like water finding new paths through stone. Winds change their courses, rain falls in places that were once dry, or withdraws from regions that depended on it. The climate becomes more variable, less predictable, a reminder that stability is always provisional, and still the Earth endures. The geological record shows no consistent pattern of catastrophe tied directly to magnetic reversals. They have happened hundreds of times, quietly woven into the long history of the planet. Forests have grown and vanished, animals have adapted and migrated, and new species have emerged under both orientations of the field. The magnetic shield has weakened before, and life has learned again and again how to live beneath a changing sky. There is comfort in this patience. The processes we are describing unfold over spans of time that stretch far beyond a single human life. Even the fastest magnetic events take generations to fully express themselves. They do not arrive with sirens or warnings. They drift in like a long season, giving the living world time to respond. If you feel your thoughts slowing here, that is part of the rhythm of this story. These are not moments meant to be grasped tightly. They are better felt as atmosphere, as a sense of depth and duration, like standing beside a river that has been flowing long before you arrived and will continue long after you leave. In the next chapter, we will step into one of these moments more closely. A brief window in deep time when the magnetic field grew exceptionally weak and the world responded in subtle but meaningful ways. We will move gently into that ancient night, not to seek drama, but to listen for what the Earth was quietly saying as its shield thinned and then slowly returned. 42,000 years ago, the world was familiar and yet quietly different. The continents sat where we would recognize them. The oceans followed their ancient basins, and the night sky held the same constellations drifting slowly overhead. But beneath that familiar surface, something subtle was unfolding, something most living beings could not see, yet would feel in ways both small and profound. The magnetic field was fading, not vanishing all at once, not collapsing in a dramatic instant, but thinning like mist at sunrise. The invisible shield that had guided particles toward the poles and kept the atmosphere comfortably distant from space began to loosen. Its strength dropped to levels far lower than anything humans have experienced in recorded history. For a brief moment, in geological terms, the Earth was more exposed than usual, its boundaries softer, its defences quieter. The skies would have told the story first. Auroras no longer belonged only to the far north or south. They wandered freely, drifting over regions where they had never been seen before. The night may have glowed faintly even at lower latitudes, not brightly enough to alarm, but enough to feel unfamiliar. The air carried more energy, more invisible motion, as particles from the sun slipped deeper into the atmosphere than they normally could. This period is known as the La Chance excursion, named after a small village where its signature was first noticed in ancient rock. It was not a full reversal of the magnetic poles, but it came close. For a time, north and south lost their certainty. The field weakened to a small fraction of its usual strength, and the geometry of the shield grew tangled and complex, as if the planet were briefly unsure of its own orientation. The Earth did not react with violence. There were no global fires ignited by the sky, no instant devastation. Instead, the response was quiet and layered, unfolding through chemistry, climate, and living systems in ways that only become clear when viewed from far away in time. High-energy particles entering the atmosphere altered its balance. Rare forms of carbon and other elements became more abundant, created by collisions between cosmic radiation and air molecules. These changes settled gently into the world, absorbed by ice forming at the poles, recorded year by year in the rings of trees, locked into sediments at the bottom of lakes and oceans. The planet kept careful notes, even if no one was there to read them yet. One of the most remarkable records of this time comes from a tree that lived through the entire event. Preserved in waterlogged earth for tens of thousands of years, its growth rings still tell the story of each passing season. Ring by ring, it recorded a surge in cosmic radiation, a clear signal that the magnetic shield had grown thin. It did not record fear or catastrophe, only change, steady and undeniable. As the atmosphere shifted, so did patterns of weather. Winds adjusted their paths. Rain belts moved. Some regions grew drier, others wetter. The climate became more variable, less predictable, like water flowing through a landscape whose channels had subtly changed. For animals and early humans living close to the land, these shifts mattered. Food sources moved, habitats transformed. Familiar routes became uncertain. There is evidence that this was a time of transition for life. Large animals that had already been under pressure from changing climates and human expansion continued to decline. Populations of early humans adapted, migrated, and experimented with new ways of living. In Europe, the last Neanderthals faded from the record around this time, their disappearance likely shaped by many overlapping forces rather than a single cause. Modern humans, already present, spread into new regions, carrying with them culture, memory, and imagination. It is during this same window that something deeply human appears more clearly in the archaeological record. Cave walls, once bare, began to fill with images. Animals, handprints, symbols, and shapes emerged in sheltered spaces carved from stone. These were not hurried marks. They were deliberate, patient expressions made in darkness, by firelight, deep within the earth. Some researchers have wondered whether this flowering of cave art was connected to the changing sky above. With increased ultraviolet radiation reaching the surface, shelter would have become more valuable. Caves offered protection, stable temperatures, and a refuge from a world that felt less predictable. Inside those quiet spaces, humans may have spent more time together, telling stories, sharing meaning, and leaving marks that spoke across generations. This idea is gentle, not certain. It does not claim that the weakening magnetic field caused art or extinction or transformation on its own. Rather, it suggests that the Lasham excursion was part of a broader tapestry of change, a background condition that added stress and uncertainty to a world already in motion. Climate, competition, migration, and chance all played their roles, braided together in ways we can sense but never fully untangle. What matters most is not whether every detail can be proven, but what the moment reveals about the planet and about us. The Earth can pass through periods of magnetic weakness without losing itself. Life can persist under altered skies, adapting quietly, finding new balances, and humans, even in times of uncertainty, turn toward meaning, toward expression, toward leaving something behind that says simply, "We were here." If your mind drifts here, imagine the soft echo of footsteps in a cave, the slow drip of water over stone, the distant glow of an unfamiliar sky outside. There is no urgency in this image, only patience. The world did not end 42,000 years ago. It changed, and then it continued. In the next chapter, we will gently examine how this moment from deep time has been interpreted and debated in the present, how stories form around evidence, and how science itself moves slowly, carefully through uncertainty, much like the planet it seeks to understand. As the echoes of deep time begin to fade, another layer of the story slowly comes into view, not written in stone or ice, but in human imagination. When the world changes quietly yet profoundly, people search for meaning, for patterns that make sense of uncertainty. This is where stories begin to gather, like water pooling in low places, reflecting fragments of truth mixed with longing. The moments when the Earth feels unstable have always inspired powerful ideas. Floods, fires, sudden cold, strange lights in the sky. These experiences do not pass unnoticed by those who live through them. They are remembered, retold, shaped into myths and warnings, carried forward long after the physical causes have softened into memory. Over time, the stories grow larger than the events themselves, filling gaps with speculation, fear, and wonder. In the modern world, this impulse has not disappeared. It has only changed its clothing. When scientists began uncovering evidence of past magnetic weakening, ancient floods, and abrupt climate shifts, the discoveries stirred something deep and familiar. The idea that the planet could change suddenly felt unsettling, especially to a civilization built on assumptions of stability. Into this unease stepped voices offering simple, dramatic explanations. They spoke of forgotten catastrophes, lost worlds, and advanced civilizations erased overnight by forces mainstream science had supposedly ignored. These stories are compelling because they offer clarity. They suggest that history moves not as a slow river, but as a series of sharp breaks, each one wiping the slate clean. In these narratives, ruins become remnants of lost empires, myths become eyewitness accounts, and uncertainty becomes proof of hidden truth. The appeal is understandable. Catastrophe feels easier to grasp than complexity, and mystery feels more satisfying when it has a single cause. But the Earth rarely moves that way. The geological record, when read patiently, tells a quieter story. Floods did happen, vast and powerful enough to reshape landscapes, carving channels through stone with astonishing speed. Ice dams failed, waters surged, valleys were scoured clean. For a long time, these ideas were dismissed because they seemed too dramatic, too sudden. Eventually, evidence accumulated, and the floods were accepted, not as global resets, but as regional events with specific causes. The lesson was not that everything is catastrophic, but that nature is capable of both patience and speed. Some took this lesson further than the evidence allowed. They began to link floods, magnetic changes, and climate shifts into a single sweeping narrative of repeated global destruction. According to these views, civilizations far older than history books admit rose and fell, wiped away by pole shifts or sudden planetary upheaval. Maps were reinterpreted, monuments reassigned, and gaps in knowledge filled with certainty rather than caution. The problem is not curiosity. Curiosity is essential. The problem is impatience. Science moves slowly because the Earth speaks slowly. Its records are incomplete, fragmented, eroded by time. To understand them requires restraint, a willingness to sit with uncertainty, to accept that some questions may never have clean answers. When this patience is replaced with urgency, the story becomes louder but less accurate. Magnetic reversals, as we have seen, do not flip continents or tear the crust loose from the mantle. They unfold over centuries or millennia, altering the sky and atmosphere without rearranging the surface of the planet. Climate shifts can be rapid, but they arise from interactions between ice, ocean, air, and orbit, not from a single dramatic trigger. Human history too is layered. Cultures emerge, adapt, merge, and fade through a web of causes rather than a single catastrophic moment. And yet, myths persist. They persist because they serve a purpose beyond explanation. They express anxiety about fragility, about the sense that what feels permanent may not be. They give shape to fears that are difficult to articulate in technical language. In this way, catastrophist stories are not enemies of science. They are mirrors of human emotion, reflecting our discomfort with uncertainty and deep time. It is possible to honour that emotional truth without abandoning evidence. The planet does not hide its history, but it does require us to listen carefully. Its signals are subtle, often ambiguous, and rarely dramatic on human timescales. When the magnetic field weakens, it does not announce itself with thunder. When climates shift, they do so unevenly, affecting some places more than others. When societies change, they respond to many pressures at once: environmental, social, and internal. Understanding this complexity can feel less satisfying than a single, sweeping explanation, but it is also more grounding. It reminds us that we live within systems that are resilient precisely because they are flexible. Change does not always mean collapse. Uncertainty does not always mean danger. If your thoughts wander here, let them. Imagine layers of sediment settling quietly at the bottom of a lake, each one carrying a partial story. No single layer explains everything, but together they form a landscape of memory. The Earth does not rush to be understood, and neither do you need to. In the next chapter, we will return gently to the present moment, to a place where the magnetic field is already thinner than usual, where satellites feel the difference and technology adapts quietly. It is not a warning, not a prophecy, but a reminder that the story of the shield is still being written, slowly, patiently, beneath our feet and above our heads. As the story returns to the present, it does so quietly, without urgency or alarm. The forces we've been following have never stopped moving. They are still at work beneath oceans and continents, still shaping the invisible space around the planet. We live inside that motion now, often without noticing it, much like fish drifting in a current too large to see from within. High above the Earth, where the atmosphere thins into darkness, satellites move in steady, patient arcs. They circle again and again, passing over the same stretches of ocean, the same sleeping continents, the same slow-turning clouds. Most of the time, the space they travel through is calm enough, held at a safe distance by the magnetic field rising from below. But over one broad region of the planet, that shield dips closer to the surface, thinning like worn stones smoothed by water. Here, the invisible feels closer. As spacecraft pass through this region, instruments grow more cautious. Sensitive systems are powered down for a while, as if the machines themselves have learned patience. Astronauts sometimes notice faint flashes of light even with their eyes closed, tiny sparks caused by high-energy particles passing through the body. There is no panic in these moments, only awareness, a quiet acknowledgement that space is never entirely far away. This weakened region is not new. It has existed for decades, perhaps longer, drifting and reshaping itself slowly as the magnetic field evolves. What is different now is how carefully we can watch it. Modern instruments trace subtle changes in strength and shape, revealing that the area of weaker protection is expanding, stretching gradually across the sky like a shadow that grows not darker, but wider. This does not mean the shield is failing. It means it is breathing. Deep below, the same liquid metal currents that have powered Earth's magnetism for billions of years continue their slow dance. They rise and fall, twist and separate, guided by heat escaping from the planet's interior. Sometimes those motions align cleanly, reinforcing the field above. Sometimes they interfere, softening it in places, sharpening it in others. The result is not a single, uniform barrier, but a living structure, always adjusting. For those who build and maintain the systems that orbit the planet, adaptation is already part of the routine. Satellites are designed with shielding and redundancy. Software learns to correct errors caused by passing particles. Orbits are chosen with care. These adjustments happen quietly in the background, much like the magnetic field itself, ensuring that life on the surface continues with little interruption. It is easy to imagine a future shaped by fear of these changes, but fear is not the natural response of the Earth. The planet does not rush, and it does not warn in sharp voices. It changes slowly, giving systems time to respond, to evolve, to find new balances. Even during past periods when the magnetic field weakened far more than it has today, life endured. It bent, it shifted, it adapted, and it continued. There is something reassuring in that rhythm. Human civilization is young compared to these processes, and our technologies are delicate in ways forests and oceans are not. But delicacy does not mean fragility alone. It also allows for creativity, for learning, for design that anticipates uncertainty. The same curiosity that drives us to study the magnetic field also allows us to live within its changes. If your thoughts drift here, imagine the planet as it is right now, wrapped in its imperfect shifting shield, turning slowly beneath a quiet sky. Water moves in long currents through the oceans. Stone settles and erodes. Heat flows outward from the core, carrying with it the energy that makes the field possible. Nothing is frozen in place. and nothing needs to be. The magnetic north will continue its wandering. Regions of strength and weakness will grow and fade. Centuries from now, the field may look different again, perhaps weaker, perhaps stronger, perhaps reorganized in ways we cannot yet imagine. And still, the Earth will be here, breathing in its own time. If you've stayed awake through this journey, you may notice how little urgency it carries. And if you've drifted in and out, that's part of the design. This story does not ask to be held tightly. It invites you to rest within it, to trust that beneath your feet and above your head, something ancient is working patiently, as it always has. For now, that is enough.